Okay, welcome to the Department of Earth, Environmental, and Planetary Sciences. And we administer the degrees in EEPS, which is Earth, Environmental, and Planetary Sciences. Uh, the contact information is here, so please do not hesitate to get in touch with us if you have any questions. Um, so, what is an EEPS major? Well, what it is we basically are trying to understand how our planet operates, and in particular, how all the different components from the ocean to the atmosphere to the biosphere to the deep interior of the Earth, that includes the crust, but all the way down to the core, how they all act together to give us this habitable planet. And we basically bring all the fields that you probably have already been introduced to, that's chemistry, physics, biology, math, computation, and data science. We bring them all together to tackle uh, the understanding of our own planet. So, what you'll learn as a major in our department is how to investigate complex interconnected systems like our planet or other planets for that matter. We work with large, incomplete data sets. We understand and are comfortable with uncertainty. We understand the connections between Earth and life. We bring together both basic and applied research, and we have a lot of opportunities for undergrads to do independent research. It's a very experiential sort of uh, major where you have hands-on experience out in the field or laboratory or computational facilities, depending on what your interests are. So it's a very diverse um, major. And we're the sorts of things we're interested in are Earth history, telling the story of our planet, the structure of our uh, Earth in the interior, and all the way up to the structure of the atmosphere. We work on Earth materials, trying to understand physical and chemical properties of rocks and water and atmospheric gases to say things about how all of these different parts of the planet evolved with time. And these are important for understanding surface environments through time. We study volcanoes for that reason as well. We're also interested in tectonics uh, and earthquakes, the water cycle, the hydrologic cycle, and all of these Earth-based concepts we also apply to studying the evolution of other planets. We have faculty in our department that are deeply embedded in missions to Mars, for example. Um, Zooming in, we work a lot on the surface environment, oceans, atmospheres, the cryosphere, waxing and waning of ice sheets. We are very interested in understanding past climate change and current climate and weather, and finally, of course, predicting future climate change from natural as well as human-induced changes. Our interests are also in the effects of climate variability and change on natural disasters or exacerbating natural disasters. We're also interested in our natural resources, from water to, in the past we were interested in oil, but we are broadening our interests far beyond just hydrocarbons. Uh, the minerals that are fundamentally necessary for building a green economy and a renewable economy is what I mean. And so we really try to teach our students how to be great stewards of the lands that we actually must use, um, but without destroying them. And our students have access to state-of-the-art laboratories, from mass spectrometers to materials characterization down to the nanoscale, to geophysical equipment and infrastructure for reconstructing the subsurface of our planet that in areas that you just can't access, you can't see. So you have to do it by various remote sensing tools or inverse geophysical inverse tools. So the EEPS major, there's a bachelor's of science, and we now have an earth science minor. We have concentrations in geosciences, planetary sciences, and environmental earth sciences. And you may ask, uh, what is the difference between the EEPS major, which has an environmental science component to it, and the environmental science major? Well, first of all, the EEPS major has a parent department, whereas the environmental science major is spread out through a number of departments. There's a reason for that. So we focus, emphasis is on bringing together, being very quantitative. Math, physics, biology, chemistry all come to bear on earth and environmental problems. Uh, Environmental science major, math is, I mean, quantitation is important too, but the emphasis really there is on integrating science with policy, social sciences, and other human endeavors. And that's why it has to be spread over different schools and departments. We are interested in Earth as a complex system and a very broad view of that, from the deep Earth to Earth life, ocean atmospheric interactions, all the way to systems on other planets. Whereas environmental science major is primarily just the Earth's surface, from the soils to the oceans and atmospheres. Okay. In terms of time, we are interested in deep time, to the beginnings of Earth, to the present, and to the future, predicting future environments. And the environmental science major is about modern and future environments, not so much the past. And finally, environmental science majors are mostly about applied research, direct applications to society, whereas we are more balanced between basic curiosity driven research and applied research that's relevant to society. We also host in our departments a program training our students in science communication. We have a magazine called Outcroppings, and undergrads and grad students play a significant role. They can become managing editors and write as well, and also help guide the direction of each issue. So it's a great opportunity, and many of our students have gone on to, in fact, science communication careers. Our students go to a wide variety of places. Academia is an obvious place. We always send them to great grad schools. Um, you can read this yourself, all the places we go, but I'll highlight a couple that may be surprising. We've had a good history of sending many of our students onto med schools, and my theory is that uh, earth science majors want to go to med school look unique because we train them how to think about everything as a holistic system as opposed to its separate parts. Of course, this comes from the earth perspective, but you get the point. Understanding the human body as a system as opposed to little tiny components of your body. Our students have also gone on to information technology. They're working in Silicon Valley, bringing their data analytics in, and then many have gone to business or law school. So I encourage you to, if you don't know much about our department, but you're a major and you're interested, come take some of our classes, a number of 100 level classes, most of them which satisfy the credit if you want to become the major. And there are no prerequisites to taking some of the 300 level courses. There's two of them this semester, one on earth materials, rocks, and one on surface processes. So really encourage you to join us. Thank you. And and here uh, are a number of contacts for you if you want to reach out to them. My name is Cin-Ty Lee, and here are a number of undergrad advisors.